Hello guys, this is Avinash and you are watching Everything Metallurgy. So friends, we have completed with all the reactions that will be involved in primary steel making. So now we'll discuss about the lance design. So what is lance? We know lance is nothing but a cylindrical tube through which the oxygen is blown into the hot metal. Okay, so we'll study the different parameters and how this lance design helps in efficient steel making. Okay, so as I just now said, oxygen is supplied through a water cooled lens. It is water cooled because to avoid any defects like differential expansion and all. We'll discuss those stuff also. Okay, so through this water cooled lens, through the water cooled lens, the oxygen is supplied into the hot metal, the tip of which is fitted with a nozzle which is known as laval nozzle. Okay, so a laval nozzle is fitted at the tip of this cylindrical tube. If this is the lance, here comes our nozzle and it will be something in this shape. Okay, so this is a laval nozzle. We'll discuss about the laval nozzle too. So this is the geometry of the lance. So generally it is about 8 to 10 meter long, and this diameter will be about 20 to 25 centimeter depending on the furnace capacity and what is the requirement of oxygen and all this stuff. Okay, so it is again operated, it will be moving up and down with the help of an electrically controlled system, gear system. Okay, now the lance life. What is lance life? Lance life is nothing but this lance is utilized for how much time, what is the duration of this lance usage. So this lance life is determined by the life of these nozzles. Okay, these laval nozzles are made of copper and this is made of steel. This lance is made of steel. Okay, so there may be failure of this lance because the failure of this nozzle. Okay, maybe due to faulty cooling, maybe due to some manufacturing defects in this. Okay, and also the differential expansion between these two. That means copper and steel, both the metals expand because of the temperature, and the differential expansion, in the sense both will not be expanded equally. Correct? So if there is any difference in the lens then of this copper nozzle or the copper tip, then also the lance will be failed. Why? Because on this, the slag, whatever is the slag present in the metal, present in the converter, it may come and it may jam this copper nozzle. So these are the different ways to lance failure. And what are the different functions of these? The different functions are, the first one is to supply this oxygen to the steel, okay, through a gaseous jet. With a high pressure, this oxygen must be sent into the metal, and it induces bath agitation also. Okay, that is nothing but stirring. Okay, stirring is also done. Okay, stirring is also done because of this. And one more thing, it produces the droplets of the metal. Now what is this droplets? We know the liquid hot metal is fed into the converter, and on this bath agitation or because of the gaseous oxygen jet, what happens? The iron liquid or the hot metal liquid is produced into many droplets. So what is the advantage of this production of droplets is that here the droplets have more surface area, so the oxidation can be very fast and rapid. So by increasing the surface area, we can increase the rate of the reaction. So in the same way, the surface area is increased due to the production or formation of these droplets. Okay, so this is about the lance. Now we'll see the most important parameter, that is lance height or lance distance. Lance height or lance distance. So for example, if this is the converter, okay, if this is the converter, here we have the molten metal and the slag layer, and this is the this is the lance. This height, the difference between the height between the nozzle and the metal or the slag layer is known as the lance distance. And why this is important? Because this explains, or this lance distance will be maintained such that the concentration of force with which the oxygen is going and hitting the oxygen level can be controlled. Okay, so why again this concentration of force is required? Because on this concentration of force, it should not happen that these this liquid iron should not spill out of the converter. Okay, should not spill out of the converter, so the force should be controlled. Okay, the spilling of iron particles, the spilling of iron particles out of the converter is called sparkling. Okay, it is known as sparkling. Clear? So at the same time, the oxygen jet or the height should be such that the maximum of the bath surface should be covered by the oxygen. Okay, that means whatever is the oxygen that is coming out, the maximum of the bath surface should be covered by the oxygen jet that we are producing. Okay, so initially the oxygen is blown soft by keeping the lance distance higher initially. Okay, why? Because if this lance distance is high, what happens? If this lance distance is high, what happens? The maximum surface can be easily reacted with the oxygen and slag can be formed. Okay, the main requirement of this high lance distance initially is to promote the slag formation, and obviously to avoid sparkling. Okay, to promote the slag formation, this is to be kept high. Okay, so initially I said, because initially there will be no slag, only iron will be there. Okay, initially only molten metal will be there, so it can be spilled out. Yes, so the slag layer will not be supporting or protecting it from the spilling. So that is why initially lance distance should be high and the slag formation is promoted and sparkling is avoided. Okay, so oxygen is blown generally for about 15 to 20 minutes. Okay, the oxygen is blown for 15 to 20 minutes. Okay, by progressively decreasing the lance distance. That means this lance is slowly kept into the converter. The lance distance is decreasing, in the sense the height between the nozzle and the molten metal layer is decreased. Okay, so this is done, and the total oxygen blow time in steel making is 15 to 20 minutes. Okay, and this lance distance should be progressively decreased. Okay, so now what is lance profile? The variation of this lance distance is nothing but the lance profile. Okay, lance profile is the variation of the lance distance. That means how we are varying the lance distance. Okay, so this lance profile is again important, because the fundamental requirement of lance profile is in all the converter steel making. The first is the formation of the requirement of this variation of this height is the first, as I said, to promote the slag formation. That means formation of FeO rich slag. Okay, why this FeO rich slag? FeO rich slag is important because this FeO content in the slag, whatever FeO is going into the slag, it will determine the oxidizing and reducing potential. Okay, we have discussed already regarding that in the slag lecture. So the FeO content of the slag only decides the oxidizing or reducing potential of the slag. So that is why firstly the formation of FeO rich slag is important or required. And then after this formation, there will be some slag metal reactions take place, and the removal of carbon and phosphorus take place. Anyhow, well, the slag formation only, other oxides like SiO2, CaO, all this stuff are removed out. But after the formation of this FeO rich slag only, and based on the conditions, the removal of carbon and phosphorus is done. Okay, so this first requirement is achieved by soft blow. Okay, what is this soft blow? Soft blow is nothing but the shallow penetration of the jet. That means the lance height is more and the oxygen is not going deep into the molten metal. It is just spreading out on the surface. Okay, so similarly this removal of carbon and the other requirements are done by hard blow. So hard blow is nothing but the oxygen must go deep into the metal and it must dissolve in the hot metal so that all the impurities like carbon, phosphorus, etc. they can easily be removed. Okay, so this is soft blow and hard blow. The soft and hard blow both are essential for refining of the hot metal, because firstly for the slag formation we need soft, so after that for the removal of these things hard blow is. So in iron making, in steel making, generally first soft blow is preferred. Soft jet is used at first to oxidize Fe, and then the lance distance is decreased and hard jet is used. Okay, so due to the soft jet, as I already said, due to this soft jet, what soft jet or soft blow is the same. So due to this soft jet or soft blow, what happens is a limey slag is formed. Okay, a limey slag is formed, and which because of this slimy slag only in the hard blow this phosphorus is getting removed. Okay, as we have discussed, for the simultaneous removal of carbon and phosphorus limey slag is required. So the carbon and phosphorus are simultaneously removed because of the limey slag produced. Okay, so this is about the lance distance and the lance profile. Okay, so in steel making, in primary steel making, the mixture of soft blow and hard blow is attained, and this is the reason why the total amount of time, the duration of oxygen blow is constant, independent of the converter capacity. So now we will just briefly study about the nozzle. Okay, so as I said, the shape of the nozzle will be something like this. Okay, this is nothing but the convergent divergent nozzle. Convergent divergent nozzle. Why? Because the shape, the cross section is decreasing and then increasing and attaining a minimum cross section over here. This is nothing but the minimum cross section. Okay, where this region is known as throat of the nozzle. Okay, throat of the nozzle. So the gas will expand from this minimum surface area to this minimum cross section area to the maximum cross section area. So we know A1 V1 will be equal to A2 V2. Okay, so from the gas coming over here, what happens is, as the cross section is decreasing, the velocity will increase to a very high extent, and from here the gas will expand with the same velocity and reaches the end of the nozzle, and this velocity of gas is greater than the velocity of the sound. Okay, that is the velocity of the gas that is generated in a level nozzle or a convergent divergent nozzle is greater than the velocity of sound. So this is known as supersonic velocity. Okay, the velocity of the gas which is greater than the sound, velocity of sound, so it is known as supersonic velocity. Okay, so always remember the supersonic velocity is attained in this type of nozzle. Okay, now generally there will be holes in this nozzle, so multi holes will be present. That means the number of nozzles or the number of holes that are present will be around 3 to 6 nozzles are present. Okay, so similarly there are 3 to 6 nozzles present in the lance, in a single lance. Why? Because the oxygen content can be distributed throughout the bath. Otherwise we can also say to improve the efficiency of the oxidation, we require more amount of oxygen. So that is why more holes or more nozzles are present. Okay, so this is about the lance design and the lance profile. So now we'll discuss about some of the developments that will be done, that are done in this primary steel making. Okay, so with this we discussed about all the reactions and also the parameters like lance design which affect the primary steel making. So this is the last topic in the primary steel making. These are developments in the BOF for primary steel making. The first one is post combustion. Post combustion, as we know, CO gas is produced on the removal of carbon in the steel making. Okay, so this is the reaction, right? C plus O gives rise to CO. So this is the reaction in which the carbon is removed. So this carbon monoxide has a very high calorific value. Okay, a very high calorific value. So if we utilize this CO, if we use this CO again, what happens? The efficiency of the temperature in the blast in the steel making is improved. So what are the different advantages of combusting this COI is higher melting rates can be achieved. Yes, as because of this combustion, more energy will be present and more amount of heat will also be available. So the higher melting rate can be achieved and the greenhouse emissions can be reduced. What are the greenhouse emissions? The same thing, the CO going into the atmosphere. So it can be controlled by this post combustion. Okay, so because of this higher melting rates, we can also use more scrap. Yes, scrap is in the solid form, so more scrap can be utilized. Okay, and because this CO is again CO is achieved, I mean this high temperature in the slag can be achieved. The slag temperature can be increased, and what happens again, the dissolution of lime and other fluxes can be easy. Dissolution of lime. Okay, and because of this dissolution, what happens? There will be decrease in the viscosity, correct? Because CaO is a basic oxide, so viscosity decreases. Okay, so these are the main advantages of post combustion. Okay, what is post combustion? The CO is again allowed to react with oxygen to form CO2. Okay, this is the reaction that we are looking at, and we are required to do this. So how this will be done? So one way is to add small orifices around this lance. So whatever is the converter we have discussed, the gas will be coming out of this converter. Okay, so this is the metal layer and this is the lance. Okay, so the carbon gas will be coming. Okay, the carbon gas will be coming in, and in the, for example, the lance is somewhere over here. That means it is kept inside the molten, it is submerged. Then the one way is to add several small orifices. That means put several holes to this lance so that the oxygen can be coming from here. Okay, so the oxygen can come here, react with these CO bubbles, and it forms CO2 and increases the temperature. This is one type. And the other type or the other method how we can do this is by keeping another lance, another inlet for the oxygen. For example, this is the steel making, generally it is done here at the top. Okay, there is a separate lance kept over here horizontally where the oxygen gas will come, and these bubbles, whatever are releasing the CO, it will be combusted and CO2 will be forming, and the energy is utilized again in the converter. So these are the two methods. One is putting several small orifices around the lance, and the other is putting a separate inlet in order to provide oxygen at the top of the converter. So this is about post combustion. And next important development is slag splashing. Slag splashing. So what is this slag splashing? Slag splashing is nothing but the splashing of the slag to coat the refractory layers. To coat the refractory lining. Okay, so this has become one of the standard practice in order to increase the life of this refractory lining. Okay, so at the end of BOF, what happens? The steel is drained off. The steel is drained out of this converter, and the slag is retained in it. And with the help of high pressure nitrogen, what we will be doing is we'll be just putting the high pressure nitrogen in the lance, and with that, what happens, because of the high pressure, this slag will be spilling onto the walls of the refractory layer. Okay, so splashing this molten slag onto the walls for a period of about 2 to 4 minutes is done. And the main advantage is increasing the refractory layer. And a slag refractory provides a consumable refractory lining which protects this furnace lining. Okay, so this is done, majorly this slag splashing practice is done because of the presence of basic oxides such as FeO and MgO in the slag. Okay, so these are basic oxides which have very high melting point, and these are refractory materials, so these can be coated onto the refractory lining in order to protect them. So these are the developments that are made in basic oxygen furnace. So there is another furnace also in the primary which is used for primary steel making, that is electric arc furnace. But for us in GATE, there is no need to study about electric arc furnace, but briefly I'll be explaining the differences between EAF and BOF. Electric arc furnace and basic oxygen furnace differences. Okay. So if you see here, the source of energy, the first difference is the source of energy. Okay, the source of energy, as we have already discussed in EAF, it is electric plus chemical energy. Okay, electrical energy plus chemical energy. As we know, graphite electrodes are utilized to arcing, and electric energy is produced, and because on the combustion and some reactions, the chemical energy is also utilized. Whereas in BOF, because of the exothermic reactions, it provides the chemical energy. Okay, it provides the chemical energy. Okay, this is the most important difference between the both. Another one is the raw materials. The raw materials that are used for iron containing particles. So in EAF, the hot metal to some extent plus DRI, direct reduced iron or sponge iron, and scrap is used. Okay, whereas here the hot metal that is coming from the blast furnace plus about some 20 to 30% of scrap is used. Okay, 20 to 30% of scrap is used. So this is the major difference in EAF and BOF, but the other operating procedure is usually same. The oxygen supply will be there, the removal of all the materials will be there, and etc. Okay, so with this we have completed the primary steel making. And from the next lecture we will be discussing about the ladle treatments and injection ladle metallurgy. So please hit the like button to motivate me to do these videos, and do share a word about everything metallurgy with all the GATE metallurgy aspirants. So thank you guys.